This video is to be used in Mr. Melcher's math class to help students add and subtract positive and negative integers using the CHIP method. It is to be used in conjunction with integer skill sheets number 4 and 5. And I want to stress to students that if they were taught another method to add or subtract positive and negative integers, and that method makes sense to them, please feel free to use that method. There are so many ways to add and subtract positive and negative numbers or integers, and a lot of students have been taught different ways. But this is for those students who are struggling. So we'll be using this with skill sheet number 4, and there's an example of the problems you'll be doing, and also skill sheet number 5. And I'm going to do a couple problems on each one, so I'm going to start with skill sheet number 4. And you'll notice that up at the top right-hand corner there, I have the rules for multiplication of positive and negative integers. And I think that's really important when we use this method using the CHIP method, because we're going to actually be using the rules for multiplication to try to simplify some of these math problems. And the reason why I say that is if I was to give this problem in my math class, 3 times the quantity 2 plus 5, and I ask my students to solve this or simplify this expression, they would probably say to me, well, we need to do the parentheses first. So 2 plus 5 is 7, so now we have 7 in the parentheses, and of course we have the 3 on the outside there. And I would ask, well, what does this imply when you have 3 next to the parentheses? And hopefully they would say that implies multiplication in mathematics. Anytime you see something next to parentheses, we're implying that we want you to multiply. So 3 times 7 would give me 21 as a final answer, and I will have simplified that expression. And it's this concept of something next to parentheses that means multiplication that we can use in other problems to try to make them a little bit simpler. And I want to do that with just the adding and subtracting. We don't really need that with problem number 1. But when I look at problem number 1, what I try to stress to the students in my class is that everything in mathematics is either positive or negative. Doesn't matter if it's a term, if it's a number and an integer, it's either positive or it's negative in mathematics. And we're either going to be multiplying, dividing, or really putting positive and negatives together to simplify things. So I would like to do this. I would like for my students to start to realize that this sign in front of the 2 implies that that number 2 is negative, a negative 2. And even though this plus sign we thought as an operation sign meant to add, we can also think of it as the sign of the number next to it. That's a positive 7. And if I wanted to draw a picture representation of that using chips, I would write a negative 2 or draw a negative 2 as 2 circles with negative signs inside them. I would do the integer positive 7 as 7 positive circles. So there's 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And if I was to put this together, I got to draw my little signs in there. So positive, 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 positive. That's my picture representation of a positive 7. There's a very important concept in mathematics that says this, that if you take a positive and put it together with a negative in mathematics, combine one positive, one negative, they cancel out, they become 0, or they go away. And that concept of putting a positive and a negative together to get something to go away is really important in higher levels of mathematics. Well, if I do the same thing here, if I take a negative and a positive and put it together, it will disappear. If I take a negative and a positive and I put it together, it will disappear. And when I look at what I have left, well, the only thing I have left is I have 5 positives. So the answer to my problem has to be a negative 2 plus 7 ends up to be a positive 5. There's 5 positives left over. That's the CHIP method. Now, it gets a little bit harder when we try to isolate an integer within parentheses, or we get something called double signs in mathematics. But when I look at this, I can eliminate that. I can say, well, this is a positive 3. I don't see the plus sign in front of it, but it doesn't really need to have a plus sign in front of it to denote that it's a positive integer. But here's the problem right here. It's this sign, this plus sign next to the parentheses. And if I just use my rules that must mean multiply, then why don't I multiply them and use my rules? I have a positive times a negative. Well, what is a positive times a negative? Well, a positive times a negative is a negative. And then the only thing left is that number 5, and I can say the same thing. I can say, well, wait a second, this is a positive 3. If I want to represent that as a picture, I can draw 3 chips. They all have positive signs inside them. I look at this and I say, wait a minute, that's a negative 5. How can I draw that or represent that as a picture using chips? It's going to be 5 circles. Each one of them has a negative sign in front of it or in it. There's my picture representation. And remember, anytime I put a positive and a negative together, they cancel out. And so when I start putting positives and negatives together, now I can do this mentally. I don't really need physically to draw this picture, but I'm hoping students can start to do this mentally. The only thing I have left is 2 negatives, so the answer to this problem must be a negative 2. Do the same thing with subtraction. Now I know that there's other methods to show subtraction, but I like to just keep things very consistent. So I'm going to go on to the next skill sheet number 5. I have the same rules up there in the top right-hand corner. And even though the operation now is subtraction, I'm really going to use the same concepts I used on the previous handout. I'm still going to try to see if I can figure out what each number is, whether it be positive or negative. I think I'm going to start with problem number 15 because this is the easier of the two. This is a negative 6. If I want to represent that as a picture, I have 1, 2, 3, 4, 5, 6. All of these are negatives. And of course, if I look at this right here, that's a negative 11. And how would I draw a picture of that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I'm pretty sure 6 and 5 makes 11. I'm going to put negative signs in each one of these.
Raquel Valdez.
And I have all those negative signs. And I'm sitting there thinking to myself, well, wait a second. I have no positives to put with any of these negatives to get something to cancel out. Nothing's going to cancel. So I got 6 negatives and I have 11 negatives. They're all negative. What do they all end up being? 17 negatives. That's the easier of the 2 subtraction problems, but I'm really not even thinking of it as a subtraction problem. I'm just trying to see if I can figure out what each number is, whether it be positive or negative. When I come over here to problem number 7, here we go. We have these double signs again. But if I just look at this, I say, well, you know what? This right here is a negative 1, so there's my negative 1. And if I use my rules for multiplication, you know that negative sign is right next to parentheses, so I can really multiply. Well, what is a negative times a negative? Well, it becomes a positive. So positive 15. Now I'm right back to where I was before. I have 1 negative. I have 15 positives. Now I could draw a chip representation of this. 1 negative. There's my 1 circle with the negative. And now here we go. 15 positives. 1, 2, 3, 4, 5, 6, 7, 8. Stop. I'm tired of doing this. I mean, I could sit here and be gone all day. I'm hoping that the students are starting to realize, wait a minute, I have a lot more positives than I have negatives. In fact, when I'm done, 1 negative is going to cancel out 1 of these positives, and so what is left? Well, what is left is 14 positives. I don't need the plus sign to show a positive number. Hopefully this video will help students understand that. If this does not help you, please see if you can find something on some of the resources we talked about in class. YouTube is a great resource to find some videos. Maybe somebody else's explanation will be better than mine.